We'll be learning about the programming language which is called Swift. And yeah, in the brief introduction, I'd like to answer three main questions. The first one is what is Swift? Second, why Swift? And third, who introduced Swift and when? So let's move on to the first question. What is Swift? Now, it is a basic programming language. As you use in your day-to-day life, the devices such as iPhones, iPads, iWatches, and iTV, everything which uses a Mac operating system or watch operating system or TV operating system, or specifically talking about the iPhone which uses the i operating system. So all that operating system and all the coding which is done to make your life easy uses the Swift language. Now, what is Swift? I like to tell you in some detail according to the bookish language. Swift is a new programming language for iOS, Mac OS, WatchOS, and tvOS apps that builds on the best C and Objective-C without the constraints of C capability. Now, why we are talking about Objective-C here is I would explain this in further slides, but right now all you need to know is the Swift apps which were made on this language were before made in Objective-C. Now in 2004, when Apple came with a new language for developers, so the Swift language was, and this I would like to explain with the help of Objective-C why Swift came over Objective-C. So let's move on to the first point in this, that Swift is easier to read. So Objective-C suffers all the words you would expect from the language built on C. To differentiate keywords and type from C types, Objective-C introduced new keywords using the @ symbol. Because Swift isn't built on C, it can unify all the keywords and remove the numerous @ symbols at the front of every Objective-C type or objective related keywords. Now Swift drops the legacy conventions. As in the earlier languages you would use semicolons to finish off all the programming code lines. In Swift you don't need to do that. So you can just write each and every line with this without a semicolon. You no longer need parentheses to surround conditional expressions like inside if-else statements. Another large change is that method calls do not nest inside each other, resulting in bracket hell. Method and function call in Swift use the industry standard comma-separated list of parameters with parentheses. Let's move on to the second point, which is Swift is easier to maintain. Now, why is Swift easier to maintain? As legacy is what holds Objective-C back. The language cannot evolve with the C evolving. C requires programmers to maintain two code files in order to improve the build time and efficiency of the executable app creation, a requirement that carries over the Objective-C. Swift drops the two-file requirement. Xcode and the LLVM compiler can figure out dependencies and perform incremental build automatically in Swift version 1.2. As a result, the repetitive talk of separating the table of contents, that is the header file, from the body, that is the implementation file, is a thing of the past. Swift combines the Objective-C header .h and implements the files .m into a single code of file, that is .swift, which is all the file that is written in the playground. Let's move on to the third point. Swift is safer. Now, why Swift is safer, we would like to explain. One interesting aspect of Objective-C is the way in which pointers, particularly null pointers, are handled. In Objective-C, nothing happens if you try to call a method with a pointer variable that is nil. The expression or the line of code becomes a no operation, that is no op, and while it might seem beneficial that it doesn't crash, it has been a huge source of bugs. A no-op leads to unpredictable behavior, which is the enemy of programmers trying to find and fix a random crash or stop erratic behavior. Now the fourth point is Swift is unified with memory management. So, Swift unifies the language in a way that Objective-C has never. The support for automatic reference counting, that is ARC, is complete across the procedural and object-oriented code paths. In Objective-C, ARC is supported with a Cocoa API and object-oriented code. It isn't available, however, for the procedural C code and APIs like core graphics. This means it becomes the programmer's responsibility to handle memory management when working with the core graphical APIs and other low-level APIs available on iOS. The huge memory leaks that a programmer can have in Objective-C are impossible in Swift. The next point, Swift requires less code. Obviously, when there is no use of semicolons and the braces, the Swift will require very less code as compared to a normal C, or here specifically Objective-C language. Now Swift reduces the amount of code that is required for repetitive statements and string manipulation. In Objective-C, working with text strings is very verbose, and it requires many steps to combine two pieces of information. Swifts adopt modern programming languages features like adding two strings together with a plus operator, which is missing in Objective-C. Support for combining characters and strings like this is fundamental for any programming language that displays text to a user on the screen. The type system in Swift reduces the complexity of the code statements as the compiler can figure out types. As an example, Objective-C requires programmers to memorize a special string tokens that were %s, %d, and %@, and provide a comma-separated list of variables to replace each tokens. So obviously when these all tokens will not be used, Swift will obviously reduce the code. Moving on to the next point, Swift is faster. Dropping legacy C conventions has greatly improved Swift under the hood. Benchmarkers for Swift code performance continue to the point to Apple's dedication to improving the speed at which Swift can run app logic. The main reason for Swift being faster is that the playground of Swift, which supports it as far as you write the code, on the right hand side of the playground you can get the expected output of the code. This is the main reason for saying the Swift language is faster. So according to Primate Labs, makers of the popular Geekbench performance tool, Swift was approaching the performance characteristics of C++ for computer-bound tasks in December 2014 using the Mandelbrot algorithm. In February 2015, Primate Labs discovered that the Xcode 6.3 beta improved Swift performance of the GEMM algorithm. That was a memory-based algorithm with sequential access of large arrays by a factor of 1.4. That was all for the Swift being a faster language. Let's move on to the next point. Fewer name collisions with open source projects. One issue that has plagued Objective-C code is the lack of formal support for namespaces, which was C++ solution for the code file name collisions. When this name collision happens in Objective-C, it's a linker error, and the app can't run. Workaround exists, but they have potential pitfalls. The common convention is to use a 2 or 3 letter prefix to differentiate Objective-C code that is written, say, by Facebook versus your own code. Swift provides implicit namespaces that allow the same code file to exist across multiple projects without causing a build failure and requiring namespaces like NSString. Next step, Steve Jobs' company after being fired from the Apple, or CG point, Core Graphics Point. Ultimately, this feature of Swift keeps programmers more productive and means they don't have the bookkeeping that exists in Objective-C. You can see Swift influence with simple names like array, dictionary, and strings instead of NSArray, NSDictionary, and NSString, where NS obviously stands for the next step, which was given by Steve Jobs' company after the Apple fired Steve Jobs. And these were born out of the lack of namespaces in Objective-C. The last and the final point why Swift should be used in comparison to Objective-C is Swift supports dynamic libraries. So unlike the Objective-C, Swift here supports all the dynamic libraries. The biggest change in Swift that hasn't received enough attention in the switch from static libraries, which are updated at the major point releases. The releases were iOS 8, iOS 7, and so on, to dynamic libraries. Now, dynamic libraries are executable chunk of code that can be linked to an app. This feature allows current Swift apps to link against newer version of Swift languages as it evolves over the time. The developer submits the app along with the libraries, both of which are digitally signed with the development certificates to ensure integrity. This means Swift can evolve faster than iOS, which is a requirement for a modern programming language. Changes to the library can be included with the latest update of an app on the App Store, and everything simply works. With this, I would like to finish off this topic why Swift should be used over Objective-C.
So let's move on to the second slide, that is Introduction to Swift.
Who invented Swift and why it was invented? Now, talking about the history, the development of Swift starting on July 2010 by Chris Leather, with the eventual collaboration of many other programmers at Apple. Swift took language ideas from Objective-C, Rust, Haskell, Ruby, Python, C Hash, and CLU, and far too many others to the list. On June 2nd, 2014, the Apple's Worldwide Developers Conference, that is the WWDC, application became the first publicity released app written in Swift. A beta version of the programming language was released to registered Apple developers at the conference, but the company did not promise that the final version of Swift would be source code compatible with the list version. Apple planned to make source code converters available for need for full release. The Swift programming language, a free 500-page manual that was also released at WWDC, and this is available on the iBook store and the official website of Apple. Swift reached the 1.0 milestone on September 9, 2014 with the gold master of Xcode 6.0 for iOS. Swift 1.1 was released in October 22, 2014 alongside the launch of Xcode 6.1, that is the playground for Swift. Swift 1.2 was later released on April 8, 2015 along with the Xcode 6.3. Then further it was released on 21st September 2015 and later on 30th September 2016 with the Swift 3.0 and on the same Xcode platform 6.3. Swift won first place for most loved programming language in the Stack Overflow Developer Survey 2015 and second prize in 2016. In December 2015, IBM announced the Swift Sandbox website, which allows developers to write Swift code in one pane and display output in the another, similar to the Xcode 6.3 playgrounds. In December 2015, during the WWDC, Apple announced an iPad executive app named Swift Playgrounds, intended to teach people how to code in Swift. This app is presented in a 3D video game-like interface which provides feedback when lines of code are placed in a certain order.
Another slide which will tell us about the pros and cons of Swift language.
It's two sides. Like a coin has two sides. You can't get both at a moment. So, talking about the advantages and disadvantages or so-called pros and cons of the language. So, Swift is easier to read and write, the first one. As it less overhead and syntax requirement, you can often achieve the same line of code using less characters. As in the earlier languages C and Java, if you had to concatenate or combine two strings, you had to use more line of codes, but in Swift this is done by very less amount of code, which is the plus operator. The plus operator can combine two strings in a less code lines, which will result in the Swift easier to use. Second point, Swift can result in short overall code length. Swift is a functional programming language, which means you can do neat tricks like passing functions as variables. This means you can write highly generic code that can do a lot of different things, reducing repetition. The repetition in Swift language is very well reduced by the functions which are used as the variables. Third point, Swift has some clever tricks as it up the sleeve. As Swift is a new language, so taking into consideration all the disadvantages of the previous languages which were there in the market, the Swift very neatly covers all the small disadvantages and makes it to use as an advantage for this language. Again, due to having elements of a functional programming language, things like map and filter are used in Swift. It is very safe. There's less memory management to worry about. Actually not less. Basically there is no memory management, which is said as when it is compared to C. Now talking about the cons, it doesn't have much of cons or disadvantages as you can say in the regular language. Now most examples out there are written in Objective-C. As Swift just came into the market in around 2004 when it just started with the scratch. So before 2004, all the programs that were written in the language are available on the internet as all written in Objective-C. So this isn't a big hindrance, but you should always at least learn to read Objective. As we come on to the end
That's
of
all
this
for the pros and
discussion,
cons of
the introduction to the Swift programming language. Now I'd like to tell you about me. So I'm Chirag Sharma and I'm pursuing my BE in Computer Sciences. and I'm currently in the final year from the college SDM College of Engineering and Technology that resides in Dharwad in Karnataka state of India. And that's all from my side. If you have any queries or suggestions or questions, anything you'd like to or appreciate the video, just comment down below, or you can get my contact details from the description given in the link. And you can also refer to my other pages, which are the Facebook, Instagram, or Gmail, whose description I am providing in the link below. Do like, do share, do subscribe the video. Thank you for watching. That's me signing off. Thank you.